Hello, this is Mark Atia back with another I2C lab demo. Um, Also the RPI Pico I2C, which we've done before. The difference here is this is going to be with an LCD. So again, I actually didn't have the hardware to do this one with the actual board, so we're here with the simulator again. Tried changing the recording settings a bit because I noticed some quality issues with the last one. So I know there's a black part on the recording, but hopefully this resolution should still be a little bit more legible as far as like going over the code and stuff. Maybe you can zoom a little bit. Maybe not. Actually, yeah, that might look okay. So yeah, we can hop right into it. This one should be a little quick. So this one actually took me forever, but going over it will be quick because actually a lot of this initialization I got. So I was having a lot of issues using initialization libraries, so that's why this code looks like so much more than it actually is. I tried um, liquid crystal, the header file, liquid crystal that's meant for Arduino, but it's supposed to be able to work with the Pi. I wasn't getting it to work. I was having all sorts of issues. I had the library manager here in Wakui and I had it added and stuff, but for some reason it just wasn't happening for me. So um, I ended up needing to find initialization. So what this is it's essentially a counter. So we have the LCD, but in I2C form connected to the Pi's I2C stuff. So data clock power ground connected to the corresponding pins on the Pico, LED resistor. LED is pin 8, resistor is just to ground, the button pin 15. So basically, I press the button, a counter is gonna start, basically time in seconds. A counter is gonna start showing on the LCD, and then the LED is gonna reflect in the same time interval to reflect that, and I should be able to press the button again to stop it. Um, yeah, pretty much it. As far as what I did in the actual code, really, I really just wrote this part. That was kind of what was necessary. The other stuff, this stuff was essentially what would have kind of came in one of those libraries. But luckily, I was able to find actually a GitHub in Raspberry Pi in which they had the initialization part already covered. And then they had a different example use for like printing stuff, but that's not what we were supposed to do here. So obviously I needed to implement my own stuff. But as far as the implementation, I don't know. I even tried this part myself, but I think I was just missing a lot of this or wrong addresses or something. But I spent most of my time trying to use libraries that weren't working. So yeah, I found on the RPI or on the Raspberry, yeah, RPI GitHub, they had the initialization code kind of here in an example. Um, Even though I just realized this right now is actually a C file, and we're working with C++. But luckily, not really. There wasn't really any difference there, and at least with how this code is written, there's no like object-oriented stuff or anything. So yeah, I used that, and then essentially, when I got down to the actual main function, I was just kind of or the main function and these other functions that I wrote are just kind of calling the methods that they use to initialize and just clear and all that stuff set. So a little bit into it, kind of gonna go over this a little bit quick. Basically, all I did was debounce and actual timer logic, and then the main function to start the loop and just kind of initialize everything. So button handler, basically some timing logic to handle how long this 300 millisecond predefined to handle not having this kind of spam and having the LED be lined up with how the counter is going. So we want the LED to blink with each run of the counter. So that's what this part is. When the stopwatch stops, the LED should be stopped. This is timing logic for the program running and the debounce timer. Here's the actual writing and updating of the LCD or timer, stopwatch, whatever. Basically, if our bool running exists, we're going to increment our time. And then I create a buffer here in which we're putting in that the string of time, basically, which is what we're printing to the LCD. And then these are just the functions that are pre-written here. So LCD clear, some up here to clear the LCD. For each time you're gonna change the display, so it'll say seconds 1. You gotta clear it every time to then say seconds 2, seconds 3, so on and so forth. Making sure that the cursor is where it should be, and then you rewrite whatever's on it with string buffer. And those functions is just calling these functions up here to do that simple stuff, and all the addressing is handled up there. And we're down here, yeah. And then this is toggling the LED. So put value to LED into the main. Pretty straightforward here. Most of it is getting handled before. Initialization of I2C. Set the pins, these pins here, to the I2C function. Pull them up. Nothing really crazy going on here. Initializations, directions. This is the callback function for the button. So, like we talked about before, I click this button, it'll take me to that press button handler function that we talked about here, which handles the debouncing and the timing, and a little bit of synchronization here. I don't remember. There was some other method that I tried to do here without just calling this function in a while loop. There was some other function that I had read about that you can use that was supposed to kind of tie to the hardware a little bit. That wasn't really working for me. So I was like, all right, we're just gonna call that timer no loop. And it ended up working fine. So yeah, so we'll give that a run. See here, the LED or the LCD is powered on. Nothing is supposed to happen until I press the button. Press the button, now it's going to count 2 seconds, 3 seconds, 4 seconds, and you see the LED is lighting up in sync with the display. And that will keep going until I decide to stop it. That stops, and that ends the simulation. You can keep it going. They'll keep being in sync. I can stop it again. And then you see it's like a lot smoother with the press of the button because of, debouncing, and which you could essentially do with a delay, but here we didn't. So yeah, that's pretty much it. That's all I got here. Fun lab-ish, gave me a lot of problems. So yeah.